Ever wondered how the height of a building or a mountain is calculated? The answer lies in trigonometry. This intriguing branch of mathematics is the secret key that unlocks the mysteries of angles and sides of triangles. Imagine a world where you can understand and quantify the relationships between these angles and sides. That's the world of trigonometry. But trigonometry isn't confined to the classroom or the textbook. It's a vital cog in the machinery of various other fields, such as physics, engineering, and astronomy. Whether it's calculating the distance to a far-off star, predicting the trajectory of a rocket, or measuring the height of a skyscraper, trigonometry is the hidden hero behind these calculations. In essence, trigonometry forms the bedrock of our understanding of spatial relationships and nurtures our problem-solving skills. It's a critical stepping stone to more advanced mathematical concepts and plays a crucial role in numerous scientific and technical fields. So get ready to dive into the world of angles and triangles. Now that we know what trigonometry is, it's time to understand its core concepts: sine, cosine, and tangent. Let's start with the concept of sine. Imagine a right-angled triangle. It has one angle that's 90 degrees, right? Now, if we focus on one of the other angles, the sine of that angle is simply the length of the side opposite to it, divided by the length of the hypotenuse. The hypotenuse is the longest side of the triangle, the one opposite the right angle. To put it in simpler terms, sine is just a ratio of two sides of a triangle based on an angle. Next up, we have cosine. This follows a similar concept to sine, but with a slight twist. The cosine of an angle in a right-angled triangle is the length of the side adjacent to it divided by the length of the hypotenuse. If you think of it as a ratio, it's just a different way of comparing the sides of a triangle based on a specific angle. And last, but not least, there's tangent. The tangent of an angle is the length of the side opposite the angle divided by the length of the side adjacent to it. In simpler terms, it's the ratio of the sine to the cosine of that angle. So if you've got the sine and cosine down, tangent is just a hop, skip, and a jump away. Let's take a moment to digest this, shall we? Sine, cosine, and tangent are all about ratios. They're about comparing different sides of a triangle based on a particular angle. And this is the magic of trigonometry. It allows us to establish these relationships, these ratios, which we can then use to solve problems. Now, you might be wondering, why does any of this matter? Well, these ratios, these relationships, they are constant. No matter how big or small your triangle is, if the angles are the same, these ratios stay the same. And this is incredibly powerful. It means that if we know just a few details about a triangle, say one angle and the length of one side, we can figure out everything else. We can calculate distances, heights, and angles that we'd have no other way of knowing, all thanks to sine, cosine, and tangent. So next time you see a triangle, remember, it's not just a shape. It's a treasure trove of ratios waiting to be discovered. It's a gateway to understanding the world around us in a way that we couldn't otherwise. And all it takes is a little bit of trigonometry. With these concepts, we can now start solving some real-world problems. Not just sine, cosine, and tangent, trigonometry also involves their reciprocals. Now, if you're wondering what these reciprocal functions are, just know they're not as intimidating as they may sound. Let's start with cosecant. The cosecant of an angle is simply the reciprocal of the sine of that angle. In other words, if you have the sine of an angle, flipping it gives you the cosecant. It's like looking at the same relationship from a different angle. Quite literally. Next up is secant. This is the reciprocal of the cosine. Once again, it's about flipping perspectives. Think of it as the mirror image of the cosine, showing you a different facet of the same trigonometric relationship. Lastly, we have the cotangent, which is the reciprocal of the tangent. It's like standing on your head and viewing the world upside down. The relationships stay the same, it's just the way we look at them that changes. Now, you might be wondering, why do we need these reciprocal functions? Well, sometimes it's more convenient to use these than their original counterparts. They offer us an alternate way to solve problems and understand relationships. For instance, imagine you're an engineer trying to calculate the height of a tower based on its shadow. Depending on the data available, you might find it easier to use the cosecant instead of the sine, or the secant instead of the cosine. It's all about using the right tool for the job. In essence, reciprocal functions are just another tool in your trigonometry toolbox. They're not there to confuse you, but to help you see the same relationships from different perspectives. They equip you with more ways to solve problems and deepen your understanding of the magical world of trigonometry. So, the next time you come across cosecant, secant, or cotangent, don't be daunted. Remember, they're not there to make things more difficult, but to provide you with more options, more tools, and more ways to understand this fascinating branch of mathematics. Reciprocal functions might sound complex, but they're just the other side of the trigonometry coin. You might be asking, why do we need to learn all this? Well, trigonometry is all around us. Let's start with something simple yet fascinating. Have you ever wondered how GPS systems work? They rely heavily on trigonometry. When your device communicates with multiple satellites, it's using principles of trigonometry to calculate your exact location by measuring distances and angles. It's like being part of a giant triangle in space. Now imagine you're an architect designing a skyscraper. You need to ensure the structure is stable and safe, right? Here again, trigonometry is your secret weapon. By calculating angles and lengths, architects can design structures that not only look stunning, but also stand firm against the forces of nature. But what about something closer to home, like home decor? Yes, even there, trigonometry finds its place. Let's say you want to hang a mirror on the wall at a specific angle to reflect light in a certain way. You guessed it, trigonometry can help you figure out the perfect angle. Now, let's venture into the great outdoors. Are you a fan of hiking or mountaineering? Trigonometry can help you calculate the height of a mountain or a tree, or even the distance across a lake, using just a simple protractor and some basic measurements. But trigonometry doesn't stop at our planet. It reaches out into the cosmos. Astronomers use trigonometry to measure distances to far-off stars and galaxies. They determine the angles between a star and two observation points on Earth, and then with some clever calculations, they can figure out how far away that star is. In the world of physics, trigonometry is used to analyze periodic phenomena, like the motion of a pendulum or the oscillation of a spring. It even helps us understand the wave nature of light and sound. And let's not forget about the digital world. Trigonometry is fundamental in the field of computer graphics. Every time you play a video game or watch a CGI movie, remember, there's a whole lot of trigonometry working behind the scenes to create those realistic three-dimensional visuals. In the medical field, trigonometry plays a crucial role too. For instance, in ultrasound technology, it helps in calculating the path and depth of sound waves to create an image of what's inside the body. So, you see, trigonometry isn't just confined to textbooks. It's a part of our daily lives, helping us understand and navigate the world around us, from the smallest atoms to the vastness of space. It's also a stepping stone to more advanced mathematical concepts, and is instrumental in various scientific and technical fields. Whether it's to calculate the height of a mountain, design a skyscraper, navigate using GPS, or understand the universe, trigonometry is there, making it all possible. So, trigonometry is not just about numbers and triangles, but it's a key to understanding the world around us. Before we wrap up, let's quickly revisit what we've learned today. We started with an introduction to trigonometry, a fundamental branch of mathematics that focuses on the relationships between the angles and sides of triangles. We then delved into the concepts of sine, cosine, and tangent, the primary trigonometric functions that serve as the backbone of this study. Not stopping there, we also explored their reciprocal functions, providing us with an even broader understanding of the subject. Next, we stepped out of the abstract and into the real world, looking at how trigonometry has practical applications in diverse fields. From physics to engineering, from astronomy to measuring heights and distances, and even in understanding periodic phenomena, the uses of trigonometry are wide and far-reaching. In essence, the teaching of trigonometry is essential for developing problem-solving skills and comprehending spatial relationships. Remember, trigonometry is not just a subject, it's a tool to decode the mysteries of the universe.